Hi there, welcome back. We're almost finished with this one, the Saba Freiburg W2, and I want to show you something as a demonstration of the next stage of work that we'll be doing here. I know that we are blessed with one medium wave station here in Madeira. Whoopee, one medium wave station, that's all we've got. And I know that it's on 1530 kilohertz. I've set my dial, set it on medium wave to 1530, and I get sweet bugger all. I get noise. If I go and look for it, there's nothing there. There it is. There it is. I don't know if you can hear the music, but that's where it's playing. So I'm getting the station that's supposed to be on 1530 on something like 1480 on the dial. Now, it's not that important when you have one radio station transmitting on medium wave. All the others are in Spanish, so it's quite easy to find. But if you were looking for on a band in a particular location where you could pick up a lot of medium wave stations, you would have a problem identifying which station it is by looking on the dial. And so what we find is that we need to adjust this. And this adjustment of getting the tuning to correspond to the dial is a great part of the IF alignment. Now, it's not just that, because we need to go a bit further. The way this works is you basically tune the frequency of the oscillator to a particular point on your waveband. The actual frequency you're tuning is the oscillator frequency minus the IF frequency, and so you'll be picking up whatever it is on that resultant frequency point. What you do also is to fine-tune the two coils before the actual oscillator stage that tune the antenna to that same frequency that you're tuning the oscillator to, or rather that you're trying to find. So when you do an RF alignment, you're actually tuning the oscillator to correspond to the dial, and then you're tuning the actual coils, the transformers that you have prior to the first tube on the radio, the ECH81. You're also tuning them to be optimum at the same frequency, so that you're you're tuning everything together at the same frequency, and it just happens to correspond to what you have on the dial. Now, we do this with all the bands. In this case, when I say all, I'm limiting myself to the AM bands because I happen to know the FM band is perfect. I found the first discrepancy here on the AM with a station that I know the frequency for, and what I need to do now is look at the rest of the bands and also look at the lower end of the dial and see how the frequencies correspond. And the way to do that is actually explained quite adequately in the instructions. So what they tell us to do, this is that instruction here, what they tell us to do is to set we can start with for example, the long wave. And the long wave, we have the two frequencies that they use for adjustment, for alignment. We have a lower frequency and a higher frequency. The lower frequency is 190 kilohertz, the higher frequency is 380 kilohertz. And on the actual dial, there's a little notch where those frequencies are supposed to be, just to help you with the actual alignment. So what they tell you to do here is you set the band that you want. In this case, we'll select long wave. We send a signal, carrier frequency, for example, 190 kilohertz, modulated, 400 hertz tone modulated at, say, 30% depth on that carrier frequency, and we inject this into the antenna. The way I normally do it is I inject it through a capacitor. Here they suggest you use a 20k resistor in series with a 0.1 microfarad capacitor. Put that into the antenna. And then you go and look on the dial to see whether you can pick up that tone at the 190 kilohertz point. And if you cannot, you move certain components. In this case, you move this inductor L, number 31, I'll show you what that is in a minute, until you get the tone at the frequency that you've set on the dial, which is 190 kilohertz. You then also adjust the two band filters, and these are number 41 and number 37, to give you the highest reading at that point. So you correct this lower end on the dial for 190 kilohertz. What you do then is you change your frequency, carrier frequency, to 380 kilohertz, and you do the same thing, but in this case, to adjust it, it's a tunable capacitor, variable capacitor, number 32, and then number 42 and number 38. This row here is the oscillator position. This is the first band filter, and this is the second band filter. So by looking at the numbers, the positions on the little drawing here, we can see that the oscillator for the 190 kilohertz is number 31 is here. That's number 31. Then we adjust 41 and 37. So 41 is there, 37 is there. That is for the lower end of the dial. The upper end of the dial, 380 kilohertz, is 0.32 for the oscillator. So that one there. And then 42 and 38 for the filters. 42 there and 38 for the filters. And that'll give us the correction of the long wave IF alignment. So we'll start with that. So I'm going to set the signal generator 190 kilohertz. The amplitude, I'll make that say 20 millivolts RMS for now. We'll see if that's audible or not. If not, we can always increase it. The modulation, I'll do 30% modulation of a 400 hertz signal, right? I send that to the antenna via this capacitor and that resistor. That's 0.1 microfarad. That is 22K. It's not far off what they suggest. They suggest 20. And that then goes to the antenna, and the negative of the or the ground of the signal generator goes to the antenna ground input. This is where I'm getting the peak signal. That's where I'm getting the peak signal. That is 190. So it's just slightly off there. So I'm going to put this on 190, and I'm going to adjust the appropriate point, which is number 31, and try and peak it at the 190. It's not much adjustment to do, just a little bit. Goes off there, go back, goes off there. That's my peak. So I'm peaking it at 190. I'm going to do the same now to the bandpass filters, and I know that is number 41 and 37. 41 is maxed out or peaked. .37 is peaked. Right, so now I've adjusted all of them. Actually, it's still slightly off. That's about right. So my 190 is set. Now I'm going to adjust the carrier frequency to 380 kilohertz. And I'm going to set the dial to 380. As I said, there's a little notch there. Now I can hear it here, a little bit low, so I'm going to set it to 380. And for the 380 I need to adjust 32, 42 and 38. So oscillator is 32. There we go. Now 42 and 38. 42 is there. There it's peaking. Going down again. 42 and 38. Going down, go the other way. Right, so I've done that. Now what I need to do is go back to the 190 and ensure that it's still correct, because adjusting the top end can move the bottom end and vice versa. So I set the signal generator to 190 kilohertz again. Move the dial across. Slightly off. So I go back to 31, 41 and 37. And that's it. That's done. So now we'll go on to medium wave. Change the selector to medium wave. And for medium wave, it says we set it at 570 kilohertz. 570 kilohertz. Leave the same modulation and see where we are. So I've got to move the dial to 570, which is there. There's a little notch over there. And it's spot on. So that one doesn't need any change. The lower end is fine. The upper end is 1330 kilohertz, so I change the oscillator to 1330 kilohertz. And I move the dial up to 1330 kilohertz, which is over here. And I'm getting it there. I want it over there. So I'll leave it over there and make the pertinent adjustments, which in this case is 30, 40 and 36 according to that little drawing. 30, 40. Now I'm going back down to test the lower end of the scale again. And it's there. Right, so that's been set. We've adjusted we've done the RF alignment for the long wave and the medium wave, and next is short wave. Short wave, it's basically the same procedure, but it gives us a reading in meters. That's what the band, the faceplate shows. It shows meters rather than megahertz. And I've taken the 42.7 meters, which is the one they indicate at the top there, and you work out that it comes out to 7.020 megahertz. So I set the function generator to 7.020 megahertz, and I have the same modulation on there, and now I'm supposed to change 27, and there's only one bandpass filter in this case, and that's 0.33. And then I will set it to 18.3 meters, which is 16.38 megahertz, and there I change 28 and 34. So all you do to work those out, there's many ways of working that out. You just go onto the web and work it out, or you can use the appropriate formula if you wish. But my generator gives me a reading in kilohertz, hertz, megahertz, and the faceplate shows me meters. So again, I do exactly the same thing. In this case, the ones I'm interested in are 2728 and 3334, and those are here: 2728, 3334. So I'll set it to the 42.7 meters, and that one is 27 and 33, so 27 and 33. And then I'll set it to 18.3 meters, and those are 28 and 34. Let's see how we get on. So I've set the dial to that little notch, which is just there, and there's nothing there. And if I go and search for it, this is where I'm getting the peak. Closer to 44. So I'm going to set it back to 42.7 meters. And I'm going to adjust those two to try and peak the oscillator and the coil. So just to make sure I don't get it wrong, it's 27 and 33. There it is. Now 33. Here we go. That seems to be a peak. That's a peak. So we've set that one. Now we'll change the oscillator to 16.38 megahertz, which corresponds to the 18.3 meter range. There's our 18.3 mark. There's a little notch on there, just below there. And if I tune it in, that's exactly where I get my peak. So this one is spot on. I'm just going to adjust the filter slightly just to test that it is in its best position. No, it wasn't. There, it's peaking. That's our peak. And that's it. We've done the medium wave, long wave, and short wave. And so if we go looking for a particular frequency on here, especially on shortwave, where you actually do get stations that will tell you exactly where to find them, like BBC World Service, Voice of America, I believe it is. They all publish where they're supposed to be on the dial. So it's quite useful to know where to find them, and to know with a certain degree of comfort and confidence that you'll find it on the dial where it's supposed to be. And that's as much of the RF alignment as I'm going to do. The FM is spot on, as I said, and it's also a slightly more finicky experiment. And I really don't want to mess the FM up, because the FM on this radio is brilliant. So this is the next challenge, and final challenge, I hope. I have to redo the cabinet. And as I mentioned in the first video, the cabinet work isn't that bad on this one. I have all the brass that needs some good polishing over here. And some of the lacquer has actually dried and is cracking, and in some places even seems to be ready to chip. I have a few scratches on here, but these are only to the depth of the lacquer. They're quite superficial. So what I've decided to try and do here is I'm going to avoid what I normally do, which is sand this all the way down to the wood. I'm going to just try and get away with sanding the surface with wet sandpaper, getting rid of a part of the lacquer and all those marks on there. See if I can get rid of the marks just on the lacquer layer. While doing that, obviously, and here's a small experiment, I'll be shining the brass work as well. I tried a little bit there just to see if the brass got shined, and it did. So I will end up with a surface that is smoothed down through maybe a couple of layers of lacquer, and hopefully I'll have all this grime out of these brass elements here. And then all I need to do is give it a few layers of lacquer, and hopefully she'll be ready to rock and roll. And that is the final video that I'll be bringing to you soon. Thanks for watching. Bye for now.